I'm Stephen Foskett, organizer of Tech Field Day, publisher of Gestalt IT, and we are here in Las Vegas. We're actually attending Pure Accelerates conference this week, and I caught up with a new friend. It's great to have you joining us here at Gestalt IT.
Oh, it's great to be here.
So first off, tell us a little bit about yourself.
So I'm Steve McDowell, principal analyst and co-founder at NAND Research. We cover all things kind of enterprise infrastructure, backgrounds engineering. I'm a systems guy, a distributed systems guy, which is why what we're going to talk about is kind of close to my heart, but yeah.
Excellent. Yeah, and I think that that's one of the things, kind of my ears perked up because we were in some of the briefings and we're talking about technologies. I mentioned CXL. I heard you talking about, some of the technologies as well, and I'm thinking, here's somebody who knows something about this. Now, we have been in enterprise tech, in any kind of tech, I guess, there's always this kind of push and pull between centralized and distributed systems, right? And that's been one of the kind of long running things in the industry is it better to have sort of standardized, centralized, consolidated systems, or is it better to have more disaggregated? What's your take?
I think if you can hide the complexity of the disaggregation, it makes a lot of sense. And that's the era that we're in. And I think, moving forward, let me say it a different way. I think that's the era that we're in, and we're expanding on that. Disaggregation is all about the interconnect, right? And it's all about the capabilities that you can push off and how well you can hide those, right? I think a number of things have come together in the past decade, right? Low-cost ARM chips, higher bandwidth interconnects. We have NVMe, we have CXL, and then you have companies like VMware that are wrapping the capabilities of leveraging kind of these accelerators, I'll call them, right? I/O accelerators, to hide that complexity from the user. So I don't even know a lot of the times that I'm using disaggregated architectures.
And I guess that's the question, though, is for people who aren't really aware of it, what is the definition? What is a disaggregated architecture?
I would call something disaggregated if we're taking a workload from a CPU and moving it somewhere else. Sometimes that's in the box. In the case of a GPU, that's kind of loosely disaggregated. It's still kind of, it's still within a coherency domain, right? But as soon as I, escape that, I'm running a function that is computed in two different places. And maybe they're in the same box, maybe they're in different boxes. And in a nicely architected system, it shouldn't matter.
Yeah, and I think that that's actually a fundamental question, because if you look at modern CPUs, so Intel, one of Intel's things that they really leaned into was this accelerator-based focus, essentially adding new instructions to perform specific tasks. Even as far back as the 386 and the 486, we had coprocessors that would offload math. Obviously today, we have GPUs. Many processors today have a neural engine of some sort that's designed for basically matrix math. Are those systems disaggregated?
I don't think so. I think, I said coherency domain a minute ago, right? I think if it's within the direct control of the CPU.
Okay.
I don't necessarily call that disaggregated. I mean, I guess it depends on what level of abstraction you want to talk about. When I think about disaggregated, it's I have a set of resources on one node that are leveraging resources on another. In the storage world, VAST data, right, very good about this, right? We put boxes together and it looks like a whole system. I think where a lot of this started and what proved the power of this was Amazon, AWS, in 2013 introduced their Nitro hardware. It's an I/O accelerator, and they scaled data centers, and it made a huge difference. That architecture has been replicated, right? Mellanox did it, and now NVIDIA sells a DPU called Bluefield. AMD acquired a company called Pensando, doing the same thing. A little geeky for a while, and then VMware with vSphere 8 supports it now, and it's invisible to the user. So with vSphere 8, my networking stack and some other functions can all be pushed down to this I/O accelerator, freeing up the CPU to do the work of the business.
So, given that, again, let's talk architecture here. NVIDIA, you mentioned NVIDIA. They are a great example in my mind of this new world of compute, where they have these the Grace and the Hopper, awesome name, Right on, guys. Nice job. They have the Grace Hopper, which is a GPU and an ARM CPU that fits into an NVLink fabric and allows you to build basically a scalable supercomputer out of disaggregated elements. That's disaggregated,
I
right?
do think that's disaggregated, and that's an in-the-box disaggregation. NVIDIA's been very good. Well, for AI, right? I don't want to stall on any I/O. I want, storage to go directly to my GPU, and they do that with GPU Direct. GPU to GPU, they're using NVLink, as you talked about, right? This is a case where the CPU is there. He's not involved in the processing. He kind of sets it up, and this other little computer inside the same box is doing all the processing. And you're right, NVIDIA has been leading that for sure.
Yeah, absolutely. I mean, they're a leader in that field. And you look at that approach, and what we're seeing now, so recently AMD introduced a CPU-less device. So it's basically for the same sort of metaphor approach. Intel has their Habana
Yes.
AI processors. And we're hearing rumors that they're going to have sort of an AI supercomputer in the cloud that you'll be able to leverage those processors with. So there's that. What other examples are there of disaggregated systems today?
Well, we also have Intel with their XPU, which looks a lot like a AWS Nitro card. So I'm doing I/O acceleration for virtualized environments. IBM, with their storage devices, they put ARM chips in the SSDs that they build, their flash core module. So you have an ARM chip in the data path. It's handling compression. They've announced that it's going to start doing ransomware detection. They're looking at entropy, and if it looks like bad data, I'm going to raise an alert to the user. That's an example of in-the-box disaggregation in kind of an interesting way. We started going down this path of computational storage a few years ago. It seemed to peter out, but IBM and even Pure Storage to some degree are doing that. They're putting intelligence in their SSDs to do things in the data path to free up that CPU to do other things.
Well, and I have to point out that Apple has been doing that with their T2 chips.
Oh, for sure.
I mean, they have a full ARM chip that's aggregating the SSD. And and Apple's a really interesting case because they're a fully vertically integrated system that uses coprocessors extensively, whether they're in the chip or as separate chips.
Yeah, absolutely. I agree with that. And the secret to being successful here is, again, to abstract it away, right? We were talking before, developers we're giving them the religion of cloud native. Abstract it away from the hardware. I don't need to think about it. Just assume that my resources are there. So NVIDIA is a good example. Apple's another good example where these are being abstracted behind libraries. So I can just say do X, Y, Z, and if there's an accelerator there, I can go and leverage that.
So I want to get to CXL. So we did a season of the Utilizing Tech show focused on CXL. We talked to basically everybody in this industry. First off, what is your impression of CXL with regard to this vision of disaggregation?
I think it's a key enabler.
Okay.
Right? It's a key enabler in that I don't need an add-in card to use it. Right? It's being built into the CPU complexes. It looks like a PCI bus essentially to a programmer to the CPU. So can seamlessly do out-of-box expansion for I/O, and it's going to be game-changing, I think, for big system design.
Yeah, exactly. I mean, one of the things that, they're starting with, just to kind of get our listeners up to speed, they're starting with a simple memory expansion. Basically, you've got DIMMs, you've got all the DIMM channels populated. You can put a memory expansion card on what looks like a PCIe slot, but is actually, or maybe even looks like an SSD connector, NVMe connector, but is actually connected as memory, right, to the processor. The next step is pooled memory or shared memory resources. Then we're going to get to basically networks of PCIe attached devices. And like you said, I mean, the ultimate goal is essentially to have a disaggregated system where each of the elemental system components, the processor, the accelerator, the I/O, the storage, the memory, is in its own world and can be combined as needed to build a bigger system out of individual discrete elements, right?
Yes, I mean, it goes back to a vision that maybe the Plan 9 guys came up with at AT&T Labs in the 90s, where I have pools of resources that I can bring together as needed, right? We really haven't had the interconnect technology to make that real. I mean, we've tried with things like InfiniBand and RDMA and you know.
Heck, I would remind you that Fibre Channel was originally designed to do this.
I did not know that.
Fibre Channel was not just storage.
Okay.
Yeah. So what's the reality check on this, though? And again, there's a rudimentary CXL shipping as part of Intel's latest generation Xeon chips and AMD's latest generation EPYC chips.
We're bootstrapping the ecosystem, right? We're just now have the ability to buy the chips that have the functionality for the memory. The software is going to follow, and then we need the hardware vendors to build the memory expanders. So it's going to be a crawl, walk, run. It's not going to be mainstream in the next 3 years. Right? We have software problems to figure out. We have compliance problems to figure out. Interoperability. It's a new paradigm of interconnect, and the entire industry needs to come together and work together. Guys like SNIA, are driving the standardization. I think that's great, and that's going to help accelerate that.
Yeah, accelerate it.
Yeah, you get it.
There you go. And I think that's going to be really interesting to see where this goes. And you mentioned SNIA. One of my questions is, what is going to be the impact of CXL, not just on servers, not just in terms of building composable servers, but in terms of building next generation storage devices or the next great whatever device?
I'm less bullish on that, and I'll tell you why. NVMe over Fabric was supposed to do that for us, right? And we have not seen, everybody wants it, nobody's using it. We're still figuring that out. And to go and re-architect storage for CXL, I think is way down the road.
Well, I guess we'll
We'll
see.
find out.
Yeah. So, what's next for you in terms of this? What are you excited about in terms of disaggregation?
Well, CXL for sure. I mean, I think this is the year of CXL enablement. Certainly is. AMD's Genoa processors and Intel Sapphire Rapids become mainstream, and we're just now starting to see servers. We're at a Pure event today. They just announced new storage boxes based on Sapphire Rapids. So we need to seed the hardware development. But I can't wait to see, as we go into the fall with Flash Memory Summit and Store Developer Conference, what these smart guys out in Silicon Valley are pitching. So I don't know. It's wait and see, and it's like kid on Christmas morning. If you're a geek.
Okay, so I'm going to finish with this then. Kid on Christmas morning, geek on Christmas morning. What do you want? What do you personally want to do with a disaggregated system? What kind of system would you want?
That's a good question. I don't use computers anymore, Steve. That's the problem. I have my MacBook, but it would be nice to plug my MacBook into an expansion chassis that's maybe shared with my iMac on my desktop.
Yeah.
Whether it's GPU, whether it's I don't need a lot of memory, honestly, or video processing. I mean, a whole range of applications. I can't wait to see what they do.
Yeah, I'm actually gonna. It's funny that you mentioned that, because I actually would have said pretty much the same thing. I would love to be able to leverage my Mac Studio and my MacBook Pro and maybe my iPhone or whatever. I mean, I'd love to be able to leverage these currently discrete elements to work together in a much more seamless way.
Sure.
And I think that ultimately that's what we could be doing. And furthermore, I will say that one of the metaphors that I use when I'm talking about CXL is Thunderbolt. Because people understand it. They understand, so I can plug a really fast hard drive or a docking station or a monitor or even, a GPU into this port on the side of my machine that looks like a USB port. And I'll tell them, that's not USB, that's PCI Express. And they'll be like, what? That can't be PCI Express. That's an in-the-box thing. Well, it's not. And with CXL, it's the same thing. I mean, we're going to have outside-the-box PCI Express, and it's going to let you do things like that with
And that's
servers.
a good analogy. CXL is the Thunderbolt for enterprise.
Yeah, absolutely. And so that's what I would love to be able to do. I would love to be able to leverage all the hardware that we have in order to do stuff like this. Well, thank you so much for joining us.
No problem.
Before we go, where can we continue the conversation? Where can we find you?
NANDresearch.com, NAND, YouTube channel as well, and on Twitter and LinkedIn, I am SR_McDowell.
Excellent, and thank you very much for joining us for this Gestalt IT Tech Talk. You'll find more of these on the YouTube channel, Gestalt IT Video, as well as our website, gestaltit.com. Thanks for joining us, and we'll see you next time.